Hello everyone. In this video we are going to take a look on how to load this X-Wing model from Sketchfab into Panda3D. And what we are going to add is also some simple PBR or physically based rendering. So the light is a little bit more realistic. But unfortunately I cannot share the link to this model, because it was available on this link, and if I copy this link and go to Sketchfab and paste it here, it looks like the model was deleted. So just search for another model or something like that. I'm just going to demoing it how to. This is a pretty high poly model, so I'm just going to demo it how to optimize it. So just reduce the textures and also convert the egg file to a BAM file and these things. So as I told you, I already downloaded as a GLTF file from Sketchfab this model before it was deleted. So I'm just going to use this model, and it is called x-wing.zip. So let's just unpack this file, and we will get a GLTF file, or a scene.gltf, a scene.bin, which contains the binary data. Also here is the license, and here is the link to that, which is not working anymore. And here are the textures. So I'm just going to open this GLTF in Blender and export it out as a Panda3D egg. Okay, so I'm still using Blender version 2.83.13 because the egg exporter works with Blender 2.8. So, and the egg exporter, you can download it from the GitHub from Kergalim, and it is called PRPEE. So it is a egg exporter for Blender 2.8. And you just have to download it as a zip, go to Blender and install it as an add-on. So I'm just going to select here everything and just delete everything. And just go to File, Import, and import as a GLTF2. Going to Desktop, and here are Sketchfab, and here is the scene.gltf. Import GLTF, and it took about 2-3 seconds to load it. And here is the X-Wing model, and it has multiple parts. So here is the body, here are the wings. Let me see here in the upper right. We are still having all these nodes, which are probably not needed, but I'm going to leave it as it is for now. So okay, let me see the vertex count on this model. You can find it on the lower right corner. So this has 70,000 vertices, 63,000 faces, and also 63,000 triangles. So it is a fairly big, it has a fairly big vertex count and face count. So we can call it a very high poly model. Okay, so now let's just click on this tab, so we will see its textures. So here it is how it looks in Blender, and it looks very nice, this model. And before we export, I'm just going to check the materials. So here is the material tab. Let's go here, and it looks like it by default now it loaded a principled BSDF. So also for the wings, principled BSDF, and okay. And let's go also to the shading tab and double check if we have here a texture input node. So without this node, the exporter won't export the textures. So this node is needed. Let's go here. We can switch between the materials. This is an empty material, so here is the body, and here are the, yes, it is a body. And we have also a second, which is this one, and Okay, it has multiple materials. But we are just going to use the diffuse texture. Okay, so it looks like that here everything is set in the shading tab. So just go back and select everything and just file, export it out as a Panda3D egg. Go to desktop, and here I have a folder called Panda-X, and I'm just going to name it xwing.egg. And here on the right side it has no animations, but I'm just going to click the apply object transform and export to an egg file. So it took about 5 to 8 seconds to actually export this model to an egg format, because as I said, it has many vertices, many faces, and the texture size is very big. So just go to the folder. Here I exported it in this folder, Panda-X, and here is the xwing.egg, and just take a look on its file size. So it is 150 megabytes. So as I said, it has many data. And let's go to the text, which contains the textures, and these textures, the first texture is 4096 by 4096. So it's a fairly large texture, and its size is 24 megabytes. Let's see the second texture. So it is also 4096 by 4096, and its size is 23.6 megabytes. So we are going to just make some optimizations, but before I do the optimizations, I'm just going to show you how long it takes to load these big files and also these big textures. Let's just first open this egg file in Sublime, because we will have the same problem as we had with the fantasy model, that the emit R is set to 5. So let's just reset it to 0. So it will not emit a red color. But this, remember that this model has multiple parts. So here is the one part of the model, here is the second part of the model. So let's just set here also the emit R to 0. Here is the third part of the model. Here I'm also going to set the emit R to 0, and it looks like it has these 3 parts. And let's just save it. And if I scroll down, you will see that, wow, this has 4.5 million rows, so it is a very big data. Okay, let's just copy everything from here and go to PyCharm, and I already prepared here an Xwing scene and a My Models folder inside is Xwing scene, and I'm just going to paste the egg file and the textures in this. It says Java IO blah blah blah, base color PNG does not exist. Who cares? So it was not copied, it looks like. Let me see one more time. My models paste. So the model was copied, and now let's copy also the textures. For some reason, PyCharm doesn't like when we are copying 2 big files, but now it is copied the 2 PNG files. Okay, now let's try to load this big file. So, and I'm just going to quickly going through the code, and this is just the usual stuff I already showed you multiple times. So we are just importing the show base, so every Panda applications must inherit from the show base, the show base module. And here I'm creating some config variables and also loading these config variables. So the one configuration is the window size, which will be 1280 by 720, and also the show frame rate meter, which will show the frame rate meter here in the upper right corner of the window. And we are loading this data. And here I'm creating a my game which inherits from show base. the init method, which also calls the show basis init method. I'm setting the background color to pure black and the camera's initial position to 0, -5, 0. So we will move back the camera on the y-axis -5. Okay, and now let me try to load this model, and I'm just going to copy from my second monitor this line, and here I'm just going to add the path to that model, so my models, and it is called X-Wing. So X-Wing, and also I'm just going to reparent this to the renderer, so it gets added to the scene graph, so it will be visible. And now let's try to load it. It will take about, I don't know, maybe 5, 6, 7, 8 seconds to load this model. And it's still loading. Okay. As you can see, that's why we have to use in games, and it is loaded. So that's why we have to use in games low poly models instead of high poly models. It took about, I don't know, 8 seconds to load this high poly model. Okay, but it loaded successfully with the textures. Let me try to load it again, because now I think Python did some caching, so the second time you load this big file, it will be a little bit faster. So let me 1, 2, so it took about 2-3 seconds to load it the second time. But let's improve this time just by rescaling the textures and also converting this model into a BAM file. So let's do the first optimization. I'm going back to my desktop, and here is the model. So I'm just going to open this folder, and here in the text file we have the two textures. And as I said, one is 24 megabytes and the second is 23.6 megabytes, and both textures are 4096 by 4096. So you can use GIMP, you can use Photoshop, you can use Affinity Photo to rescale these images. I'm just going to use the built-in image editor in Windows, and here is the resize. I'm just going to click on here, and I'm going to select the percentage, and I'm just going to give it 25. So it will scale down the image by 75%, so it will be 25% of its original size. So let's do this. Okay, and also save it, and also open the second image, edit, resize, select the percentage and set it to 25, so it will scale down the image by 75%. And also make sure you have checked this maintain aspect ratio, and OK, and just save it. And now let's take a look on the images. So the first image is 1024 by 1024, and its size is 2 megabytes, so it's not 24 as it was before. The second image is also 1024 by 1024, and its size is 1.99 megabytes or 2 megabytes. So, and if I open it up, we just, yes, for static rendering or something like that, when you have to render for animation, you can use that big images, but for games you should optimize your texture sizes. So don't use in games that large textures we had before. So now let's copy these rescaled images into PyCharm, and I'm just going to overwrite these two. So text and paste, and overwrite for all. Okay, now let's take a look, and it is about the file size. The X file size is still large, so it is still 150 megabytes. So as I told you, Python does some caching, but the cache was deleted probably because I overwrote these PNG files. So now let's try to load it again, and now it loads much faster than the first time. So let's just also improve the model just by converting it from a human readable EGG file to a non-human readable BAM file or binary file. So here in my documents folder I have a virtual environments folder, and here I have several virtual environments, and here is the Panda 1.10.10, so the latest version of Panda is installed under this environment. So I'm just going to this folder, and under the lib side packages here is Panda3D. You will find here, not here, but Panda tools. Here is the Panda tools. If you go here, you will find a bunch of useful executables. What we are going to use is the egg to BAM converter, which is this one, egg to BAM.exe, and this comes pre-installed with Panda, and you can find it as I showed you in your virtual environment when your Panda is installed. So to actually use this egg to BAM, I'm just going to activate this virtual environment. So let's open a CMD window here, and let's type activate. And I'm also going to move this CMD window into this, or open the CMD window in this folder, so where the xwing.egg is. And CD, just copy the path to this folder and paste it here. So now we are in this folder where this egg file is located. And I'm just going to copy from my second monitor the command to actually convert. So we are going to use the egg to BAM executable, which I showed you a minute ago, and we are going to convert the xwing.egg to output.bam, although I'm just going to name it not output but xwing.bam, x-wing.bam. So in this will, before I continue, as I already showed you properties, this is about 150 megabytes. And now let's take a look how big is the BAM file compared to the egg file. And should I? Okay, it's still converting. Okay. Now, as you can see, writing xwing, it took about 3-4 seconds to generate this BAM file, and now here it shows the initial file. So the egg file was 150 megabytes, and the BAM file is only 5 megabytes. So it is 30 times less than the egg file. But you can read the egg file because it is a human readable file format, but you cannot read a BAM file because it is a non-human readable file format. It is just a bunch of binary data encoded in hexadecimal. So, but this BAM file, the BAM file contains the same data as the egg file, just in binary format. So let's copy this BAM file, and here in the PyCharm, and I'm just going to paste it in the My Models folder. And now let's load this xwing.bam. So if you are loading egg files, you just can give it without the file extension. But if you want to load BAM files, you have to give it the file extension. So xwing.bam. And now let's take a look. It loads, and it loads much faster than it loaded the egg files. So it took about half second to load. So we optimized this 3D model just by reducing the texture size and also converting the egg file to a BAM file. And the next thing will be to actually, I'm just going to add to this scene a very simple PBR lighting. But before I add the PBR lighting or the PBR, I'm just going to show you the basic lighting which comes with Panda. So I'm just going to uncomment this line, which imports from my light setup model the setup point light and also the setup ambient light. And let's go to the light setup module. So we have a setup ambient light, and it just creates an ambient light, and it also has a setup point light which creates a point light. And I'm just going to also first remove or comment out this line, which we will use this for having shadows. So it sets the point light color, it creates a node path, and also sets the node path position. And yeah, so here after we loaded the model, I'm just going to do this. Set a point light, and I also need a light location, which will be just a tuple. So light location will be x50, y0, and z50. So here when we call the setup point light, we are setting up the point light on the model, which is the x-wing, and here's the light location, which is just a tuple, and here it is indexed just by position 0, position 1, and position 2. On the setup ambient light, we are also setting up the ambient light on the model itself, and the ambient light does not need any position. So let me take a look now. Okay, so here it is how it looks just with the point light and the ambient light. Let me remove the ambient light for a second, and you will see that now the bottom part of the model is completely dark or completely black. So that's why we need an ambient light. And now also add back the set shadow caster, so it will cast shadows, and this will be, so it creates a shadow, a texture in memory, and this texture size will be 1024 by 1024, and on this texture it will cast the shadows. But before that, I also have to call this line, which will set the shader auto, so it will generate a shader. Okay, now we have shadows, at least on some parts of the model. But it is still, not bad, but it's still just too dark. So that's why we are going to use PBR instead of just this simple point light and simple ambient light. So if you want to use the simple PBR module for Panda3D, here is the link to that module on GitHub, and I'm also going to add these links to the video description. So it was created by Moguri, and it is called Panda3D Simple PBR. So it says a simple, basic, lightweight, no frills PBR render pipeline for Panda3D. And it was updated about 2 months ago last time. So to install it, just scroll down, and here is the command. So pip install Panda3D Simple PBR. I'm just going to copy this, go to my desktop, and here is the CMD window, and I already have here activated a Panda3D environment. So let's just paste it here. Oh, not this. Okay. I copied the wrong thing, it looks like, so copy it again, Ctrl C, and paste it here. So pip install Panda3D-simple PBR, and it says that requirements already satisfied, so I already installed it in this virtual environment. So let's go back to PyCharm, And to actually use the simple PBR model, we have to import it first. So let's just import like this, import simple PBR. And the next thing will be just initialize the simple PBR. Okay, let's say here. I'm just going to remove this enable fog equals true. So initialize the simple PBR and that's all. So the model is now, it will use by default this PBR rendering pipeline. So let me take a look. And now as you can see, the model is much more brighter than it was before. Just remove this line, the simple PBR.init. It is darker, although not bad, but it is darker. And let's add back the simple PBR.init. And it is much brighter now. And I think it looks a little bit better. Okay, so lastly I'm just going to add some simple rotation for this model. Before I add the rotation, I'm just going back to GitHub to the simple PBR page, and here you will find a lot of settings you can set for the simple PBR, like I don't know, if you want to use GLSL version 3.3, you can copy this, use _330, paste it here and set it equal to true. And so these are inputs to the simple PBR init function. And now let's run it. So the only problem is that under the hood it probably uses some older GLSL version, because although it works, but here it says that the global variable GL frag color is deprecated after version 1.2, and we are forcing it to use version 3.3. I mean OpenGL version 3.3, which also uses GLSL version 3.3.0. So I'm just going to remove this. But if you want to set some variables to this simple PBR init, here are all the options. And now let's do that light movement. So off screen I just finished the code. So here I set the camera position to -20 on Y, so it moves the camera back, and on the Z-axis 8 units, so it moves the camera up. And also set the camera's pitch rotation, which is the rotation around the X-axis, to -18. So the camera now is back and it looks down on the model. And the rotation is added here, so I just created here a rotate method, and I'm also getting the frame time, although the frame time here is not needed. I'm just going to comment this out. And here I'm just setting on the self.model.setAge, so it sets the heading of the model to self.angle. Angle is here created as a member variable, and it is set to 0. And so we set the age or the heading to self.angle, and here we are incrementing the angle in every frame by 0.2. And also here on this line I added this method to the task manager, so it is being called in every frame. And now this model rotates slowly, and I think with the PBR lighting it looks a little bit better than without the PBR lighting. So that's all what I wanted to show you in this video, so thanks for watching and have a nice day.